7.6 for freshman house algebra, solve systems of linear inequalities. So you already did systems of linear equations and you've graphed linear inequalities. Now we're just going to do systems, so it just means more than one. But before you do that, I'd like you to just stop, like always, practice what we did the day before. The more you do it, the better you get at it, always. Okay, here's what I got. So this is in slope-intercept form, so I started at -1 and went up to over 3. I noticed that it does not have an equals underneath, so that gives me a dashed line. And then I have to decide what side to shade, so I used 0, 0. Plugged it in. It is not a true statement, so I shade the side that does not have 0, 0 in it, because 0, 0 is not a solution. There's a lot of knots there. All right, here. You're running one ad that costs $6 per day and another that costs $8 per day. So I have two different variables I wrote here. You can spend no more than $120. So this is actually should be less than or equal to, but it doesn't really make a difference to solve what you're asked for here. So what I did was I wrote, okay, $6 for the first ad, $8 for the second ad has to equal 120 or less than. If I used the y-intercepts, I could find out that if I plugged in 0 for y, I could have 20 $6 ads. If I plugged in 0 for x, I could have 15. So here's a combination. 20 and 15 would be one combination that would work. All right, so let's practice this. Graph the system of inequalities. A system of inequalities is just like a system of equations. It's got two or more inequalities, and your solutions to the system will be the overlapping shaded area. Since we're graphing more than one inequality, we're going to get overlapping shaded areas. And that's what we're looking for. All right, so I have to graph both of these inequalities. I know I got junk on my hands. It was from the copier. Sorry. All right, so I'm going to start with this one. Y is less than 3x. If I just think of it like this to graph, and I know that my y-intercept is 0, we just don't usually write it. I can then realize that this is the slope. So I can start at 0 and go up 3 over 1. And then I have to notice that that is going to give me a dashed line. So I connect those two with a dashed line. When you do inequalities, they don't have to be super straight because you're not really looking for the point of intersection with inequalities. And look at how crooked that line is. I'm sorry. You're looking more at the shading, okay? So that's my first one. Now, normally I would test with 0, 0 to find out what side to shade. But my line goes through 0, 0, so that's not going to help me. So I got to choose a different point. I'm going to test with 1, 1, which is absolutely acceptable. We're going to plug in 1, 1 and see if it's part of the solution for this inequality. So I'm going to use my inequality, plug in 1 for y and 1 for x. Is 1 less than 3? No. So this is not part of the solution set. So I got to shade this side. So I'm not going to shade it super heavy because I'm going to be looking for overlapping. So I want to be able to see where that overlapping is. Okay? So we did the first one. Now let's graph the second one. I noticed that this is in slope-intercept form. I'm going to do it with a different color. Sometimes different colors really help when you're doing this, so you can definitely see the overlapping. This is the y-intercept, so I'm going to start at 1. This is my slope. It tells me to go down 2 over 1. It's a solid line because it's got that equal underneath. Solid. So I'm going to connect those two. Okay? Now, even though it kind of looks like it, this does not go through 0, 0. So I can use 0, 0 to find out what side to shade. Here's 0, 0. Okay, so I'm going to plug in 0 for x and y and see if this is a true statement. Is 0 greater than or equal to 1? No, it is not. So that means I've got to shade above the line where 0, 0 is not. So I'm going to do that for that inequality. And here I can see that this is my overlapping area. So I'm going to make that dark so it's easy to see that this area right here is my solution set, meaning that any ordered pair in this area would make both of those inequalities true. If I pick this point right here and I were to plug it into x and y for this inequality and this inequality, it would make it true. And that's true for any of those ordered pairs right there. Okay? All right, turn it over. So here we have another system, but we've got 3 inequalities, which is fine. So I'm going to graph the first one. Remember, these are lines. So I'm going to write here y is greater than or equal to 0. Maybe you want to think of it like this just to come up with your line. This is saying that all the y's are 0. The only place on this graph where all the y's are 0 is right here on the x-axis. Oh, I already drew my line without checking for sure that it's solid, but it is solid. Okay? My inequality says, all right, for this particular instance, all the y's are greater than 0. So that tells me what side to shade. So I got to shade above. So I'm going to do it again pretty lightly. So that's my first inequality. Now I'm going to do x is greater than -3. Again, you could think of it like this. This is telling you that all your x values are -3. All x's are -3. So if I go over here where x is -3, that means my line is going to be up and down here because all the x's are -3 there. And I have to use a dashed line. So I'm going to do that. That represents where x is -3. And this is saying, okay, for this instance, all your x values are greater than -3. Now, if you think about the number line, this is the way they're bigger than -3. If you go this way, they're smaller. So you have to shade all of these this way. Because any single point in this area, your x-coordinate's greater than -3. All right, let's do this last one. I'm going to do it in yellow. I think you can see. So 2x plus 3y is less than or equal to 6. That tells me again it's going to be solid. Okay? This one is dashed. All right, this is in standard form. So if I write it like this, just to help me get 2 points, I could use a baby table. If I plug in 0 for y, that goes away. And I just have to divide both sides by 2 to find out that x would be 3 when y is 0. There's one of my points. I plug in 0 for x, because that's what this table is telling me to do. If I divide both sides by 3, then my y would be 2. And I have 2 points that I can plot. And I know I'm going to connect them with a solid line. So the first point is over 3 up 0, and over 0 up 2, and I connect them with a solid line. Now I have to decide what side to shade, and I can certainly test here with 0, 0. Let's just try it out. See if 0, 0 is part of the solution set for this inequality. 2 times 0 plus 3 times 0. Is that less than or equal to 6? This is 0, this is 0. Is 0 less than or equal to 6? Yes. So I got to shade below this line where 0, 0 is, because 0, 0 is a solution. And then I got to step back and take a look at what I've done here. And I notice that there's only one little area here that has overlapping coloring. So I'm going to make that just a little bit darker. That is my solution set, right inside there. That means all the ordered pairs there would make all 3 of these inequalities true. Even the points on this line, because it's a solid line, and on this line. So everything here would make those inequalities true. All right. A logo contest requires that the logo width be between 3 and 5 inches, the height no less than 2 inches, and the sum of the width and the height no more than 9. Write and graph a system of linear inequalities that describes the information given. Okay, to help me out here, I'm going to say that x is the width and y is the length, or the height, excuse me. This will help me write my inequalities. So if I go back up here, it says the width has to be between 3 and 5 inches. X is my width. This tells me that it has to be greater than or equal to 3, but it also has to be less than or equal to 5. This tells me that x has to be between 3 and 5. The height is no less than 2 inches. My height is y. It can't be less than 2 inches. It's got to be greater than or equal to 2. And here it says the sum, that means add, of the width and the height, so x plus y, is no more than 9. It means it has to be less than or equal to 9. This is necessary in order to help you write these inequalities. You decide what your unknowns are. Okay? Now, let's graph these. This one, hopefully you remember from up here, same kind of thing. This tells me that all the x values are 3. It's going to be a vertical line through 3. And I have to use a solid line. So I'm going to go over here to where x is 3, 1, 2, 3, and I'm going to draw a solid line. It's not just a point, it's a line. Before I shade, I'm going to do this one because I know it has to be between 3 and 5. So this is telling me that all my x's are 5, so that's also going to be a vertical line where x is 5. Also solid. So this tells me right here that it can only be between 3 and 5. So I'm going to shade right in between there for now. I've taken care of both of those. X is between 3 and 5. All right, now let's do this one. Y is greater than or equal to 2. Remember, it's a line where all the y's are 2. So if I go up here on the y-axis to where 2 is, horizontal is where all those y's are 2. It's going to be a solid line. So I'll use a different color for that. Okay. And then I've got to decide what the shading is. So it says all the y's are greater than 2. So I'm going to shade above that line. Now remember, don't do too much heavy shading because ultimately you're looking for the overlapping. And you won't be able to see it if you shade too hard. All right, let's do this last one. So if I set this like this is in standard form, and I use a baby table if you need to. You might not need to. You might just see it already. 0 for y, 0 for x. If y is 0, x is 9. If x is 0, y is 9. So I have my 2 points that I can graph. I know it's going to be a solid line. So I'm going to go over to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And connect them with a solid line. Okay, so for this one, I'm going to test with 0, 0 and just see if I shade this side or I shade that side. So I'm going to plug 0, 0 into the inequality. Does that make that true? Is 0 less than or equal to 9? Yes. So 0, 0 is part of the solution set. So I got a shade below, which is the part that includes 0, 0. Okay, now step back and look at your picture. There is only a very, very small area on this graph where all those colors overlap. Can you see it? It's right here. So I'm going to shade that darker. That is the only area where these points would meet all these requirements. Okay, so let's use that to answer this question. you enter a logo that's 4 inches wide. Remember, this is X, and this is 6 inches high. Use the graph to determine if it meets contest requirements. So this is telling me go over 4 and up 6 and see where that point is. Over 4, 1, 2, 3, 4. Up 6, 1, 2, 3, 4, 5, 6. Oh, that point right there does not fall in my shaded area. So it does not meet the requirements. 4, 6 does not fall in the solution set or the shaded overlap area. So it is not a solution. And I have to stop now because you're coming. Bye.